In this video, we discuss another property of liquid at rest, which is called surface tension. Surface tension. That is the tension on the free surface of the liquid. Now, before going into the details of surface tension, we must know the types of molecular forces. Molecules are bonded together with forces. Two types of molecular forces come in. One, cohesive force. Cohesive force. It is the force of attraction between like molecules. For example, a water molecule and another water molecule, when they attract each other, we call that as cohesive force. Then, second one is adhesive force. Adhesive force. There is a force between two different types of molecules. For example, water molecule and glass molecules. Suppose during rainy days and all, if you spill water on the glass, you can see that the water will be sticking to the glass. So there will be an attractive force between the water molecule and the glass molecule. That type of force is called adhesive force. Sticking force, we can say. And based on this, we have given the name for the stickers and all that, glues and all, we call adhesive. Okay? Adhesive system. Adhesive, we can say. So, these forces are basically responsible for the tension on the free surface of the liquid. So, before going into the details of surface tension, we must come across, or we must know, some terms relating to. One is sphere of influence. Sphere of influence. You can see that when we talk about the cohesive force or adhesive force, there will be a range coming up to which the force can act, and that is called the range of the force, molecular force. It's a small distance, molecular distance on X coming. And then, what is sphere of influence? Means, if you take a molecule and take the range as the radius. Take the range, molecular range as the radius. You can draw a sphere around this particular molecule. And that sphere, imaginary sphere, over which the molecule can exert its influence, we call it as what? Sphere of influence, we say. Okay? So, range of the force, then sphere of influence. These are the terms coming along with. Now, let us see the surface tension. Surface tension is the property of the free surface of the liquid at rest to act like a stretched membrane and trying to occupy minimum surface area. Okay? So you might have seen that the insect can walk on the surface of the water without sinking. And also you can keep the small piece of blade, metal blade, on the surface of water without sinking. Small pin also can be kept like that. And then you can see that if you touch your dry finger on the surface of water and pull it up, you can see that the upper face of that water will be coming along with lifting up a little bit. That means there is a sticking properties. All these are due to what you call the tension effect of that free surface to act like a stretched membrane to trying to occupy minimum surface area. Got it? Okay. But how to define that surface tension? For that, I take an example. Suppose I consider a frame here, and inside that frame I am making a film. A thin film is made inside that. Thin film. Thin film. What is meant by thin film? Thin film is a surface with negligible thickness. Thickness is of the order of molecular range. Such a very small sheet with a very small thickness is called a film. Soap film and all you have seen that. And I take a weightless string and tie the ends together. And that string is dropped on this film without breaking the film. So what I am doing is that string is taken and tied end to end, and I am placing that string on this film. And I wait for some time that the string stick with the film. After that, I break the film inside the string. The moment I break the film inside the string, what I can see is that, some of you might have got that idea now, all of a sudden the irregular shaped string will automatically become circular in shape. And inside there is no filament is broken. Okay? That means that from all sides there will be a pulling forces coming on the string, and that stretches the string from all sides, and effectively that becomes a circle. This stretching force, this pulling force acting from all sides, okay, along the length of this string is taken to be the surface tension. So that I can define surface tension as surface tension is equal to the force acting per length. The force acting per length of the system, free surface of the liquid. Force acting per length of the free surface of the liquid is taken to be surface tension. So it is not force alone, surface tension is force per length. And its unit is Newton per meter. Its unit is Newton per meter. Now why it is pulling from all sides? Because once this inner part is broken, the molecules are pulling them together and trying to reduce the surface area. It's an inherent property. So due to that, there is a stretching effect is coming. Okay. So mathematically we can define the surface tension as is the force acting per length of an imaginary line drawn on the free surface of the liquid perpendicular to the line and tangential to the free surface of the liquid. Perpendicular to the imaginary line and tangential to the free surface of the liquid. This is the definition for surface tension. Now, why this is acting, the free surface is acting like a stressed membrane? Let us see. To explain that, I consider a beaker with water taken in. There is water taken in this, and it is filled with water, and the water is at rest. Water is at rest, and this is the free surface, right? Now, if I take a property in terms of molecular concept, if I take a water molecule here, will be experiencing force from all sides, that the net force on this one will be 0. Like that here also there will be a sphere of influence, and force will be there from all sides, that the resultant force on that will be 0. Like that, when we take here again, like here again, but when we consider a molecule on the free surface of the liquid, then the sphere of influence comes like this. See this? A hemispherical part in the liquid and other hemispherical part in the air. But there will be force from the water molecule throughout the hemispherical part. But there will be force due to air molecule from upper hemisphere. But the problem is air molecules cannot be static, and therefore effectively force from this part can be neglected. So the molecule on the free surface of the liquid will be having an effective force or resultant force downward. Like that, if you consider all the molecules on the free surface, all will be having that pulling downward effect, but they cannot go down because molecules are there below. So effectively all this pulling down effect effectively coming on the free surface in the form of a stretching effect. So the free surface of the liquid acts like a stretched membrane.